Hey everybody, this is Larry. This is day 22nd of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord, and here we go to week 4, right? Okay. Binary tree zigzag level order traversal. That's a pretty long mouthful. Given a binary tree, return the zigzag level order traversal of its node's value. From left to right, right to left for the next level and alternating between. Come again? From left to right, and then right to left, and then left to right. Okay. That seems like just a regular traversal, and then you could do it with like BFS or level traversal, but it seems like, and then you just reverse the order you do it for certain levels. I think that's how I would do it. I'm just thinking right now whether like there's a cool way to do it, but maybe there is. But because on the first level, like, is there an easy invariant to do it as like on one pass, quote unquote? I mean, I guess you can by pushing stuff on a stack or something like that for the next level, but I think that's just like a lot of bookkeeping. So for now, I'm just going to do it the normal way. And yeah, today I'm just going to do the breadth first search version, or level order search, or whatever, level first search or something like that, depending on how you want to call it. Yeah, but I'm going to start with a queue, and that's how I'm going to start. User collection.deck instead, because in Python that is, but in your language there might be just a regular queue, and then queue dot and root. I guess you could always do it with 2 stack now that I think about it a little bit. Yeah, because for each level, the number that you process, or the node that you process last, will process first. So I don't know if I recommend this. It's just that I want to play around a little bit today. So let's muck around and play around a little bit, and then we'll kind of see how this shakes out. I don't know how. I think if I was an interviewer, maybe I would play it safe, or I would talk to an interviewer just to like get all of these ideas, just to play around. But for now, I guess I will see how that goes. Yeah, because especially for me, some of this for this today will be for practice, and I want to try something new to kind of practice my thing a lot. And that is what you should do sometimes with your tree traversals, right? Is that you always do that for search, and you always do that for search. Try to mix it up so that you figure out how you learn a little bit. Okay, cool. Yeah. I think there's another while loop here, so that's why I'm just thinking about how to write this. But I'll just write it normally for now, which is for. Do I always? I think the only thing that's a little bit tricky is that you still have to click. You have to still do dot left or dot right, and it depends on what order you're coming from. Because if you're going from right to left, then technically you want to process the right subtrees first, so that the stack would make it all okay. So, so maybe it's not. Maybe it's tricky to get it quite the way that I did. So I'm going to go back to using queues. Yeah, and just do this. And there are a couple of ways you could do this with both either breadth first search, or just this level order search or whatever. Yeah, so current node is equal to q.0, q.pop left, and then we just want to put next q, dot append node dot left and node dot right. I have to check them. I know. Hang on. Okay, and that will allow us to process one at a time. And then for levels, we can just do something like level is equal to this, and this is what we return eventually. And yeah, so then at every level, we could just at the beginning we could do levels dot append a new empty array, and then here we could do levels the last element of it we append node.value, I think. Yep. Okay, and then maybe here we have a while true. It's kind of like a do while loop, to be honest, but yeah. And then now we go if length of next q is equal to none, then we break. Otherwise, q is equal to next q, and next q we set it to nothing. Well, back to exec. Cool. And now it should give us a level order search, and I know that right now it's not going to give us the right order. It will just give us the, ideally it should give us the level order, and then that'll allow me to do just step by step and try to figure out what I want to do next, right? And here I noticed that which is what I expect, so it's correct. It matches my expectations. So now I know that I have to reverse every other level because zigzag. So and then that's pretty much all we have to do, right? We could do something like you could maybe have done something with whatever, but for me I'm just going to do so we want to reverse every second element. So I mean I'm just going to write this as dumb as possible. So let's start at 1 while index is less than length of levels. Level sub index dot reverse, and then index increment by 2. Oops. And yeah, and there we go. Let's submit it. Ooh. Okay. So again, I guess I missed the case where the empty array. I think usually I check this, but today maybe I'm just a little bit not mindful. So yeah, if root is none, return this. Usually I check at least some case as well, but I don't know why I didn't check it today. So yeah, so definitely as usual though, you have to focus and have to remember all these checklists in your head, like remembering to write test cases. Okay. So that looks okay again, so let's submit it again. I was a little bit overconfident / ready to go to sleep because it's 3 a.m. But yeah, accepted, so that's good. So what is the running time of this, right? So each element is only going to be accessed once. Basically when it gets constant number of times, O of 1. Each of them gets at most inserted into the queue once, and each of them gets at most dequeued once, and then append to the levels once, and at most once for the reverse, because reverse you just do O of 1 for time for each element. So at most each element is going to do like a couple of operations. So so this is O of n linear time. In terms of space, everything we do is output sensitive, and what I mean by that is that it is the lower bound, because that you are going to output each element at least once and at most once, ideally. So it's going to be linear output. So yeah, linear times and linear space. And yeah, that's all I have for this problem. Let me know what you think. Again, try to experiment with it as you can. And hit the like button, hit the subscribe button, and I will see y'all tomorrow. Bye bye.